This is a physics problem dealing with one-dimensional kinematic motion. Difficulty is medium. This involves interpreting graphs. Okay, so for this question, we are given two objects are heading towards each other. Okay, one at t equals 0 is 20 meters. Okay, that's the position. Position of object 2 at t equals 0 is negative 40 meters. Okay, here's the graphs. This is a velocity by time graph. So this is, as time gets more positive, right? This is going to be our origin, right? This middle line is when velocity is 0. We have positive velocity, negative velocity here, right? Okay. These are linear lines. So when velocity decreases or increases linearly, that means we have a constant acceleration. Okay, that means we're going to be using our average velocity equation for distance. Okay. So back to here, right? So we know that these two objects are heading towards each other. Okay. So in order for that to happen, okay, we want them here. Maybe this will be easier. Pretend we have a graph here. Okay. We have, this is 20 meters, right? This is going to be positive. This is going to be 0. This is not to scale, obviously. This is negative 40 meters. This is negative, positive. Okay, in order for object 1 to approach object 2, he has to have a negative velocity, okay? And in order for this object to approach object 1, it must have a positive velocity, okay? That's the only way that they'll approach 0. So imagine that. Just imagine that, right? This one's on the positive side, this one's on the negative side. If they're going towards each other, that means they're both approaching 0, right? So if they're both approaching 0, they're both approaching each other, okay? So now this is a positive velocity, okay? So now the slope is negative, but that doesn't necessarily mean that our velocity is negative. That means our acceleration is negative, okay? Our acceleration is against our direction of motion, okay? Do not get confused, okay? This one is a negative velocity, okay? That means that even though the slope is positive, he's not going in the positive direction. He's going in the negative direction. His velocity is negative until he reaches velocity equal to 0, okay? So negative velocity all the way. This one's positive velocity all the way until they reach 0, okay? So now what we want to do is we want to find out where these two objects stop. Do they crash into each other? If they don't crash into each other, how far away are they from each other? Okay, so what we're going to do, since we know acceleration is constant, we already know we're going to use our average velocity equation, right? So that means our final position, right, xf is equal to x initial plus our average velocity. So remember, he's positive, right? Positive position. In order for him to be approaching 0, he's going to have a negative velocity, right? So our average velocity is going to be his final plus initial, right? Which is 0 plus negative 20, right? So negative 20 over 2, right? Which is negative 10 meters per second times time, right? Which is delta t, which is our duration, right? Which is 4 seconds, right? So that means his initial position is 20. So we have 20 minus 40, right? Okay, because the seconds cancel. So that means his final position is equal to negative 20 meters, okay? So he's going to be over here, right? Negative 20 meters, okay? This is not drawn to scale, okay? So it looks like it's going to be kind of close, right? So let's see. So object 2 starts at negative 40, and we're going to put him with the positive velocity, okay? So same thing, right? Constant acceleration. So we're going to use average velocity, right? This is of 1. This is going to be final position of 2, right? Is initial plus average velocity, right? So in this one is 12, right? So we're going to add initial plus final. So that's 0 plus 12 divided by 2. So that becomes 6 meters per second is his average velocity times his duration times delta t, right? His duration is 3 seconds. Okay, So 3 seconds here. Okay, solving his initial position is negative 40, right? So this becomes 18, right? So his final position is negative 22 meters, okay? So that means object 2 is going to stop right here, negative 22 meters. So what's the distance between them? Distance between them is the absolute value of their difference, okay? So we have negative 22, right, minus negative 20. So we have a double negative here. That becomes plus. That becomes the absolute value of negative 2. That becomes 2 meters, right? So there's 2 meters of separation, which is easy, right? You could see there's 2 meters of separation there. So they don't crash. They don't crash, and there ends up being 2 meters of separation, okay? So just keep in mind what the question tells you. Your starting position, are they heading towards each other? Are they going away from each other? Is one going towards the other? You know, and make sure that you know, in order for that to happen, what do their velocities have to be? Okay, because it's very easy to put the positive velocity with the positive, you know, with the positive starting position, you know, or to possibly think that this is a negative velocity when it's not. Okay. Also, too, you want to check your graphs, make sure this average velocity equation only works if there's a constant acceleration. In this question, I know that line's a little wavy, but it is declared acceleration is constant, okay? So that means we can use our average velocity equation. All right. Hope that helped. Leave a comment if you have any questions or if you want me to solve another problem. Otherwise, thank you, and give a like if it helped. Thanks.